This video is from a course on Amazon Aurora PostgreSQL. I'm covering Aurora Serverless V2 overview in two videos. In part 1, I'll discuss how Aurora Serverless V2 works, and in part 2, you will see Aurora Serverless V2 in action. In this lesson, I'll introduce you to the Serverless V2 database instances. You'll learn about the cluster capacity range setup, how Aurora scales a Serverless V2 instance, and you will also learn about the operating cost of a serverless instance. You already know that Aurora architecture separates the compute and storage for database clusters. Storage shrinks and grows based on the usage. In other words, storage scaling in Aurora database clusters is automatic. Compute capacity for an instance in the provisioned cluster is static. That is, it does not change with the load on the instances. The provisioned instance capacity adjustments require manual intervention by the users. To avoid capacity challenges under heavy load, users may just use larger instances, but this will lead to overcapacity challenge. That is, user will pay for capacity that will not be used at all times. This is the problem that Aurora Serverless addresses by offering automatic vertical scaling for the compute in the Aurora cluster. Aurora Serverless V2 instances are scaled automatically at runtime based on the load on the instance. User just needs to specify the capacity range. The minimum and the maximum capacity for the cluster is specified in terms of Aurora capacity units or ACUs. Aurora uses a special instance class name for serverless instances. The serverless instance class name is always set to db.serverless or just serverless. One Aurora capacity unit or one ACU is equal to 2 GB of memory, equivalent CPU capacity, and network bandwidth. Cluster capacity range is specified by setting the minimum ACU and the maximum ACU at the cluster level. The minimum and the maximum ACU are specified as multiples of 0.5 ACU. Since the capacity range is specified at a cluster level, all instances in the cluster will be assigned the same capacity range. Smallest capacity for the serverless instance is 0.5 ACU, which is equivalent to roughly 1 GB of memory. Maximum ACU can be equal to or greater than the specified minimum, and the ceiling for the maximum ACU is 128 ACU, which is equivalent to approximately 256 GB of memory. If the maximum is set equal to minimum, then there will be no instance scaling. As a result, the instances in the cluster will behave like the provisioned cluster instances. To estimate the available vCPU and network bandwidth, one needs to consider an equivalent R5 or R6G instance. Let's say the instance capacity is set at 32 ACU, which means that the instance will have approximately 64 GB of memory. An equivalent R5 instance will be DBR5 2x large, which has 64 GB of memory. And this instance class has 8 vCPUs and up to 10 Gbps of network bandwidth. Let's look at another example. Let's say the maximum capacity of the instance is 128 ACU, which is equivalent to approximately 256 GB of memory. Comparable DB instance class is R5 8x large that has 32 vCPUs and a network bandwidth of 10 Gbps. At runtime, Aurora monitors the pressure on the serverless instance and dynamically adjusts the capacity to appropriate levels. The capacity changes are adjusted by 0.5 ACU or above. As an example, let's consider a cluster with a single serverless instance. Let's say the capacity range is 1 to 4 ACU. When load is run against such a cluster, Aurora will dynamically adjust the capacity allocated to the instance. The graph here depicts the ACU in use at point in time. Instance capacity was 1 ACU when the load was initiated against the instance, and then within a short period of time, it went from 1 ACU to 3 ACU. While the load was running, capacity stayed around 3 ACUs, and once the load subsided, capacity reduced from 3 ACUs to 1 ACU. The database instance scaling rate is not constant, as it depends on the load on the instance, size of the database, and the difference between the minimum and the maximum specified in the cluster capacity range. Scaling up is almost instantaneous, whereas scaling down is slower. A serverless instance is a drop-in replacement of a provisioned instance. A true serverless cluster will have only serverless instances as depicted in this setup. Each of the instances will scale independently. Aurora also supports a mixed cluster configuration in which the cluster consists of provisioned and serverless database instances. Here is an example in which we have a writer instance that is provisioned, whereas the replicas are both serverless instances. The behavior of the cluster will be that Aurora will adjust the capacity of the readers based on the resource usage resulting from the read traffic. Let's look at another example. In this example, the writer is serverless, whereas the readers are provisioned. So the writer instance will scale with the change in load due to writes, but the capacity available for reads will remain constant at all time. Now let's discuss cost of Aurora cluster with serverless instances. Important thing to keep in mind is that savings in a serverless cluster comes from the savings in the compute cost only, as the storage cost and the I/O cost does not change as a result of use of serverless instances in a cluster. Let me explain with an example how Aurora calculates the cost of a database instance. Cost of the serverless instance is based on per second usage of the ACUs. The cost per hour varies by region, so please check out the Aurora documentation for the per hour cost of serverless instances in your region of interest. In US East 2, the cost is 12 cents per hour. Let's say there is a single serverless instance in a cluster with a capacity range of 4 to 8 ACUs in US East 2. For the sake of this discussion, I'll assume that the capacity changes are instantaneous. So in the first 10 seconds, there is no load on the instance, so it consumes 4 ACUs. The cost will be 4 times 10 times cost of per ACU per second. So this is the cost for operating the instance for the first 10 seconds. Let's say for the next 20 seconds, the instance consumed 6 ACUs. So the cost will be 6 times 20 times cost of ACU per second. Next 20 seconds, instance consumed 4 ACUs and then 8 ACUs for 10 seconds, and last 10 seconds, the instance consumed 4 ACUs. To get the operating cost of the instance for this period, we'll add up the cost of each of the intervals depicted in the graph. And so this is the cost of running the instance for 70 seconds with the specific load characteristics that I have depicted here. Time to go over the key points from this lesson. Aurora dynamically adjusts the capacity of the serverless V2 instances. Serverless V2 instances are drop-in replacement for provisioned instances. User needs to specify the capacity range, which consists of the minimum and maximum Aurora capacity units. One Aurora capacity unit or one ACU is equivalent to approximately 2 GB of memory. Aurora adjusts the instance capacity by 0.5 ACU or higher. Key point to note is that the rate at which the capacity changes is not constant. The VCPU and the network bandwidth allocated to the instance may be estimated by looking at the equivalent R5 or R6G class instance. Cost of capacity usage is calculated for the instance on per second basis.